Okay, next we're going to look at units of measurement. So it's really important to know how to take measurements in a lab, especially when we start doing that in the lab. Okay, it's important to know what you're doing and how to do it, what to look for, all of that. So when we're taking measurements, we have two different parts. We have a numerical value and we have a unit. Okay, if you only write down the measured quantity and not the unit, that measurement is meaningless. So be very careful. Make sure to always write down the number, the quantity, but it also needs to have a unit. Okay, because if you just say I have 13.2, well, is that 13.2 grams? Is that 13.2 milliliters? You know what I mean? It's very important to have that unit along with it. Also, when we're in the lab and we're writing down numbers, all measurements are subject to error. Unfortunately, a lot of it depends on the instruments that we're using. We have to be careful and make sure we're writing down all the significant numbers that is given, and we'll talk about what that means. But sometimes we don't, so that's an error. A lot of the error that is in the lab is usually because of ourselves. But I mean, that's just it, there will be error in reporting numbers. Okay, so let's look at this measurement here. We're going to measure this green line. We're going to use this ruler here. And the most important thing is to always get as many significant figures as possible out of our measurement. So I'm going to explain what that means. So here we know for sure, so this is in centimeters, we know for sure we're at 2 centimeters, right? That's a for sure thing, okay? But then we have to look at the smaller dashes to see, to be more exact. Okay, I can't just write down this is 2 centimeters because that's not right. We know it's between 2 and 3. So if we look at the bigger dashes between the 2 and 3, we have 1, 2, 3, 4, 5. Well, let me write on here. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10th place, right? Okay, so we know for sure we're at 2.5, right? Not quite to 6. So for sure it's past the 5, but not quite to 6 yet. Oh wait, I think I have a line. Whoops. Yep, I forgot to put that on there. So let's try that again. Okay. So for sure to the 5, not quite to the 6. So we have 2.5. But that's still not the correct measurement. It's in between the 5 and the 6. So we've got to go a little bit further. So this is what I mean by making sure you get as many significant figures out of your measurement as possible. Because if we were to only report 2.5, that's not correct. We're missing numbers. Okay, so now the little number, or the little dashes, we're going by 2, 4, 6, 8, right? I can't write them by the dashes because it's too small. So we're at 2, 4, 6. So the line is for sure past or in between the 6 and the 8, right? So we have our measurement is going to be 2.5. Those are for sure. And we know it's past the 6, not quite to the 8. So these numbers are for sure, right? 2.5. Wait, I wrote that down wrong. I'm sorry. Let's try that again. 2.56. I'm not sure why I wrote a 4. 2.56 we know is a for sure, okay? But anytime we take a measurement, we always estimate one more number. Okay, so we know for sure these 3 numbers, but then we're going to estimate our last number, and it really doesn't matter what you estimate. It's not right on 6, so if it was right on 6, we would say 0. But it's not right on 6, so we're going to say 5. Okay, so this number was a guess. It was, oh, I ran out of room. We'll say estimated. Okay, always estimate that last number. Okay, so again, if it's right on the line, you would just estimate 0. But since it's past the line, it doesn't really matter what you estimate. Okay, you could have said 4, 3, it doesn't matter. Just estimate one more number after the, we call these right here, reliably known. This is hard to write on here, sorry, reliably known. Okay. Okay, so we know for sure 2.56, and then we estimated the 5. Okay, so we're getting 4 significant digits out of this measurement. That's as much as we can get. So again, if we only wrote down 2.5, that would be an incorrect measurement, and we're not getting as many numbers as we can. Okay, so it says uncertainties exist in measured quantities. So let me show you what I mean by that. Whoops. Not sure how to do that again without bringing that up. Let's try this. Okay, so if I have two, I'm not sure what just happened here. Okay, so if I have 2.565, okay, so we estimated that number. So the uncertainty lies with that number. So to show uncertainty, we say plus or minus 0.001. So there's our uncertainty. It lies with the 5. So all this plus or minus business is just showing that the 5 could have been greater, so it could have been a 6, or it could be less. It could have been 4. So that's where the plus or minus comes in. So you always just put a 1 with the estimated number. Okay, so I could write, oh, let's just say we had 2.56. Okay, let's say we estimated the 6. Okay, so then our uncertainty would be plus or minus 0.01. Because again, the uncertainty lies with the estimated number. So it could have been a 5, it could have been a 7. Okay, so you don't have to write this with your numbers, but that's what the uncertainty means. Okay, let's, okay. Let's see if I can get to the next slide. There we go. Okay. So when you're taking measurements, we want the quantity, the number. We also want the unit. Okay, for chemistry, we use the SI unit system, and it's based on the metric system, but it's called the International System of Units. So that's what SI stands for. So we have the SI units listed here. For length is meter. For mass, it's kilogram. Time is seconds. We're not going to deal with electric current. We will with temperature. It's Kelvin, and amount of a substance is mole. So those are the ones we're really going to be concentrating on. Some other examples of units would be hours, minutes, yards, feet, liters, grams, pounds. So there's lots of different units that we're going to be using. And we're going to be able to change in between those units here pretty soon. Okay, along with the unit, you can add a prefix. Okay, so you can add that to a basic unit. So let's just say, for example, use gram. Okay, gram is a basic unit, but I can attach the prefix kilo right here. So here's kilo to gram. So gram is our basic unit, and gram, we just use a G, but I can attach kilo to gram. And so now I have kilogram, right? So I can do that with anything. I can do that with seconds. I could have kiloseconds or kiloliters. You know, I can attach the prefix kilo to any basic unit that I have. Or I can do any of these. I can do deci, centi, milli, micro. So what all these prefixes do is make our number smaller. Okay, so if I had 3,000 grams, let me come to this real quick. Okay, so if I have 3,000 grams and I don't want to work with such a large number, all I have to do is add kilo to my unit, and now I have 3 kilograms. So that's the same quantity, but adding that prefix to my basic unit gives me a smaller number. Okay, let me do another example here. Okay, let's say I have 0.006 liters. Okay, I don't want to work with that number. So if I add milli to liters, then I'm going to get 6 milliliters. Okay, so it's just a way of shortening the number or condensing it instead of having to work with a number that has a lot of zeros in it. You know, we just have to add that prefix to it. So I want you to know these prefixes. I want you to memorize them. I won't give them to you on your exam. So I want you to memorize, let's see here, pico to kilo. Okay, so we use most of those prefixes quite a bit. So just remember, if you memorize the exponent portion, so this portion, oops, not that one. This portion right here, that's the relationship to the basic unit. So just to give you an example, we'll use micro. So if I have 1 microgram, whoops, that's not micro. Microgram, that's the same as 10 to the negative 6 grams, okay? So I always tell people you're going to put 1 with your prefix. So here's your prefix, 1 with the prefix, and then the exponent goes with the basic unit, which is grams. Okay, so these take quite a bit of practice. Okay, so make sure you start working on these, working on the homework portion in MindTap with these, because again, a lot of people get them confused. But if you'll start working on them and start memorizing them, hopefully they won't be too bad.